All right, you may not know, but there is another way to measure angles. It's not just degrees, we also have another way, radians. Yay! Let's make it more complicated. So what you want to think of, and what it means, what a radian is, it has to do with the circumference of the circle. And I'll explain why in 2 seconds. So we have this circle here with a radius of 1. So remember, circumference equals pi times the diameter. So what's the diameter of this guy? Well, everyone's yelling out 2 pi. Correct? Because the diameter is 2. So the circumference is 2 pi. If the degree of the angle, which is the central angle, is 50, so let's say this is 50 degrees. So this is two different things we're going to put kind of together. What is the degree of the arc? And as you guys know, that's also 50 degrees. So if I tell you that the circumference of the whole circle is 2 pi, then all the angles are 2 pi. And that's how we think of, that's what radians are. So there are 2 pi radians in a central angle. So 2 pi is your 360 degrees. So that's your full circle. So then we just break it up. Well, 180 degrees is half of 360. So that would be 2 pi over 2, or half of it, or just pi. 90 degrees is half of 180. And 270 is, I guess 3 times 90. 3 times 9, so it would be 3 pi over 2. And 0 is just 0. So this is another way to measure angles. So basic ones like the quadrantals, the 180, the 90, 270, and the 0, we can figure those out, using their relationship to 360. But what about an angle like 227? What do we do? Well, we simply multiply it by pi over 180. So if you want to get radians, you need pi on the top. So pi in the sky. I just made that up. It's pi in the sky when you're converting to radians. So you would multiply 227 by pi over 180. Whatever number you get is the answer. Okay, so that would be, I guess, 3.96189, whatever. All right, if you don't know where pi is in your calculator, you hit second, and then the little tilde thing, I call it the to the button. It's second there, will give you the pi. So try these, round it to the nearest hundredth, and see if you can get those. So the answer's here. Multiply, sometimes I like to put it over 1 so you realize 135 is in the top. 135 times pi over 180 is this, and then round it to the nearest hundredth, that's 2 decimal places. So for each one of these, 225 is 3.93, 240 is 4.19, and 330 is 5.76. Now there's another way this question is asked. Sometimes they do ask this question to find the number of radians in terms of pi. And that means we don't put pi in our calculator when we do it, but it will be a pi in the answer. So in terms of pi means, okay, I got this. In terms of pi means pi will be in your answer. Okay? So when we do this, we just do it exactly the same way as we did before. I like to have that over 1 for this particular kind. So we multiply times pi over 180. But what we actually type in our calculator is 30 over 1 times 1 over 180. And in our answer, we know that this pi was on top, so we're going to put a pi on the top. So this becomes pi over 6, or 1 pi over 6. So what's actually happening here is we really are just reducing. So if I take, how many times does 30 go into 30? Well, it goes once. And how many times does 30 go into 180? Well, that would be 6. So we get a 1 pi on the top and a 6 on the bottom. However you choose to do this, if you want to just straight reduce it, or you want to put it in your calculator like this, it doesn't make any difference whatsoever. The answer will turn out to be the same. Generally, we don't put a 1 there, but if you feel the need, feel the need. Try 45, 120, and whatever one else is there. So whether you did a calculator way or you did it reducing way, I showed the reducing way. The calculator, there's really nothing to it. You just leave the pi out of the calculator. So this would be 45 over 1 times 1 over 180. You just have to remember that the pi is on the top when you're done. And then it reduces it for you and all that fun. Okay, you get 2 pi over 3 for this one and 8 pi over 9 for this one. The other helpful thing, which is more helpful for us because radians is very unusual for us, is converting from the radians that they give us to the degrees that we were used to. So pi over 3, what we just do is we multiply by the flip of what we did the other time. So we multiplied by pi over 180, but now we don't want radians anymore. We want to get rid of the pi. So we put it on the bottom. And what happens is the pi does cancel out for ones where pi exists. If not, we just, again, put this whole thing into our calculator. Just type it in, and you get your answer out. So this particular one would be 60 degrees. Now, this might be different on yours. I'm not quite sure if I fixed the typo or not. So if this one on mine is 10 over 9. Okay, there's no pi. So there also can be ones where there is no pi. Whatever, you just put it in your calculator. So then, after you've put this into your calculator, you get 63.6619, blah, blah. So if we're saying it to the nearest hundredth, 63.66. Okay, same deal with 3.2. So it doesn't have a pi, but the pi still goes on the bottom. It's kind of already in there, you know. You're already in the pi's already been multiplied in, kind of thing. Put it in your calculator and figure it out. So then when you do that, you get 183.34, whatever. So 183.34. Since pi is 3.14 and pi is 180 degrees, it kind of makes sense that that's pretty close to 180 degrees. I like it when it works out like that. So then you have to do what we did yesterday, sketching an angle, but now we have to do it with radians. So you have to convert. So if you don't know what this is, you have to convert it. So if we want to convert from radians to degrees, remember we want to get rid of the pi, so the pi goes on the bottom. And then we solve this one, the negative's still there, so it becomes negative 30 degrees. So then we just sketch it. So negative, it starts at the x-axis and goes down very little, down 30 degrees, and there you go. So then you would label it with negative pi over 6. That's an arrow, it's supposed to be. So it's negative, so it's going down. Wonderful. So you can try the rest of these sketching the angle, so try that out for yourself. Okay, so for this one, I converted it to degrees because I understand 135 degrees a lot better than 3 pi over 4. And I got 135, that's right there. So 135 is the same as 3 pi over 4. Okay, this is negative, so you know it's going down. And try that out. So for this one, when I converted it, I got negative 510. Now that's bigger than, or less than, if you want to think of, than 360, the negative 360, so I added 360 to find a coterminal, and I got negative 150 degrees. So I just went down to negative 150, so this is 90. I guess that maybe that's not the best, you know, it's in quadrant 2, so it probably should have been over here a little bit. But whatever, it's the same difference. So then, since it's negative, we go down and we loop around that full 360, and then we go to the 150. Then make sure you label it, and you're good. So it's not perfect, but it's perfect, so it's all good. Find an angle coterminal, so we should convert this, and then convert it back. So we'll see how that goes. So there's two ways actually to deal with this one. You can actually add 2 pi, or subtract 2 pi from it, or you can convert it to degrees and then find something coterminal, and then convert it back to radians. It's up to you. I'm going to do the converting method. So try it out. Okay, so this isn't the only way that you could do this problem, but I converted it to degrees. Then I subtracted 360 to find something coterminal. You could have also added 360. I just like to get closer to 0 to 360. It's just my way. So then it goes to 90. I know 90 is pi over 2, but if you don't remember that, convert it to pi over, multiply by pi over 180, and you get pi over 2. Done.